Welcome to conditional probabilities. So we have a couple new words here. Probability, we are referring to the likelihood or chance of something happening. Probability itself, we usually use in decimal form, but it's basically exactly what we were doing in the previous video, the two-way tables video, when we were calculating percents. So the idea here is sometimes we don't want to know the percent chance or the probability of something happening out of the total population. Sometimes we want to focus on a specific subgroup. So we want to focus on subgroups. And calculate the percent chance of a subgroup falling into a certain category. So, for example, a study was run on the relationship between work status and student status in Peralta. The data is summarized below. In the two-way tables video, we created a two-way table with just 15 students. This one is built based off of 200 students. The data is completely made up, by the way. So in total, we had 69 students that worked full-time. So here's our 69 students that worked full-time, 78 students that worked part-time, 53 students that didn't work at all, for a total of 200 students. And I want to know, if a student selected at random worked full-time, what is the probability they were a full-time student? So again, when I say what is the probability, you're essentially asking what is the chance, what is the percent chance they were a full-time student. Although again, typically probability we put in the decimal form don't convert to percent. So here's our verb. We're looking at what is the percent they were a full-time student. So this is our numerator. The they we are referring to is we are limiting ourselves to, so we're selecting at random someone that worked full-time. So we are limiting ourselves to only those who worked full-time. So if we limit ourselves to only those who work full-time, then we are only looking at the row that refers to students who work full-time. So we are going to completely ignore all of the other numbers in the table. We are only looking at students who work full-time. looking only at that row, then we only had 69 students to consider. So here, there were only 69 students who fell in this category. So that's our denominator. Of those 69 students, we only had 7 who were full-time students. So we were looking at 7 out of 69. Uh, 7 out of 69 is approximately 0.10. So we could refer to the probability as 0.10, or we can convert to percent. And so we have approximately a 10% chance. And so these are more or less the same types of questions we were asking earlier. The difference here is that instead of being out of the overall 200, we are limiting ourselves to only a row or column. So the next question, we are limiting ourselves to only those who worked part-time. I lost the, what is the probability here? What is the probability? They were a full-time student. So limiting ourselves to those that worked part-time, we are now looking at this next row, only considering those who worked part-time. We now are looking at a total of 78 students, out of whom 29 were full-time students. So we are looking at 29 out of 78. And if we do 29 out of 78, we have about 0.37. Convert that to percent. And we have about a 37% chance. Next up, let's look at those that do not work. So if a student selected at random did not work, that's what we are now limiting ourselves to. We want to know what is the probability that they were a full-time student. So going back to our table, we are now looking at those that do not work. So we only are looking at a total of 53 students here. And of those, 22 did not work. Sorry, 22 were full-time students. So we have 22 out of, what was that number? 53, which is approximately let's go with 0.42. We could always convert that to percent. And we have approximately a 42% chance that a student who does not work is a full-time student. And finally, we are now going to switch to student status as our condition. If a student selected at random was a part-time student, now I want to know what is the probability they worked full-time. So now instead of limiting ourselves based off of their work status, we are now limiting ourselves based off of their student status. Looking back, we are now limiting ourselves to part-time students. Of our part-time students, there were a total of 142 part-time students. And then we wanted to look at those who worked full-time. So 62 of those 142 worked full-time. So we have 62 out of 142. 62 out of 142 is approximately 0.44. Converting that to percent, we have approximately a 44% chance. So this is conditional probability. Instead of looking out of the total 200 students, we are limiting ourselves to a specific row or a specific column.